Let's take a look at the pre-assignment for 2.5. Make sure that we're up to par, ready to start 2.5 next week. First up, what is another name for the zero of the function? Call it a root, a solution, or x-intercept. Where do these zeros go when you graph them? On the x-axis, because they are x-intercepts. Now, number 3, graph a function with zeros at -1, 2, and 5. So -1, 2, and 5. Well, that's not 5. And 5. So we just need something that goes through those 3 points. So go up and down and back up. And this is a cubic, of course, because there's 2 turning points, and there's only 3 zeros, so that would be a degree of 3. Now, graphing number 4 here, obviously we're going to use some Desmos here, because we don't have to do it by hand. So x cubed minus 2x squared minus 4x plus 8. Then we'll do this, hit the gear, hit the create table, and get some points. I think I want at least a couple more. So we can graph, let me get a good color here. We can graph -2, 0, then -1, 9, we have 0, 8, we have 1, 3, 2, 0, and then we go back up to 3, 5. And now we just kind of connect them to make sure they look like the graph on the left. And they kind of do, but mine's kind of wonky, if anything else. But that's okay. So now we want to factor this. So the easiest way to do it is factor by grouping. I guess we check for a GCF first. There isn't one. So we take an x squared out of that first pair. We're left with x minus 2. Take a -4 out of the second pair. We're left with x minus 2, which is what we want. So we got an x minus 2. When we factor that out, our leftovers are x squared minus 4. Now, we can still take the square root of those. We can do our difference of 2 squares. So we get x plus 2, x minus 2, and we still have this x minus 2 here as well. So what do you notice or wonder about the graph in relation to your factors? Well, if we look at the opposite, that would be 2, -2, and 2. Well, that's where our zeros are, at -2 and 2. And more importantly, because 2 is there twice, that's why we kind of have it bounce off the x-axis and keep going up. But we'll talk more about that later. All right, let's continue with the prerequisite topics for section 2.5. Simplify each radical. So we don't want you just throwing this in the calculator or Desmos. We want you simplifying it with our perfect squares, basically with our perfect squares. So we can do this one of 2 ways. We can split this up into root 4 and root 7. Square root of 4 is a perfect square. It's the biggest perfect square that goes into 28. So of course, square root of 4 is 2. We can't do anything to the square root of 7. It's prime. So that's what we got. Now, if that's not as straightforward, do our factor tree. We can even start with 4 and 7. And I like to cross out the number when I break it down, and then 2 and 2. So what we want is 2 of something. Well, we got 2 2's, so we bring that out, but this 7 doesn't have a pair, so it stays inside. And we got the same thing. Same thing with number 2 here, root 54. Let's say we do our factor tree. We think, I don't know, 27 and 2. I know 2 goes into it because it's even. 27 is 9 and 3, and then 9 is 3 and 3. So we want to get down till we can't factor the numbers anymore, and that's what's going on here. So we got a pair of 3's that'll go on the outside, but then we have 2 things left over. So we just keep them together, we multiply them together. So you get 6 here. So that's how we can find our simplification of square root of 54. We can also split it up into perfect squares. That'd be the square root of 9, square root of 6. That gives us 3. That still just gives us root 6, and that's the same thing that we got doing it the other way. Now number 3, we're getting crazy. We have a negative inside the square root. So right away, we should remember that I is the square root of -1. It's not -1, it's the square root of -1. So we separate that off. This turns into I. This turns into 3. So together, they're 3i. So if you see a negative inside a square root, just, I like to say, poke out your eye. Take that negative out, make it I, and then just simplify the radical. So similar with number 4. Now 75 is not a perfect square. Okay, so we'll break down 75. We won't worry about the negative yet. So we got 5 and 15. 5 is prime. 15 breaks up into 5 and 3. Both of those are prime. So we have a pair of 5's. We have this 3 left over, and that negative is going to give us an I answer there. So that's how we can just deal with the negative, make it I, and then just simplify like we've been simplifying otherwise. Now, when would we use that? Well, when we're doing something like 5 through 8 here, using the square root property to find exact solutions. So x squared equals 20. Well, we have to get rid of that squared. So what's the opposite of squared? Square root. So these cancel out. And we get plus or minus, because a negative times a negative is a positive, but a positive times a positive is also a positive. And the square root of 20. Well, of course, we have to simplify the square root of 20. We break it up into 5 and 5, which is 2 and 2. So we got a pair of 2's. So we got the plus or minus first, and we bring out the 2 for the pair that we got. And then we leave what's left in the radical of 5. And those are our 2 solutions. When it's x squared, there should always be 2 solutions. Whether they're real or not depends on the other values, of course. So moving on to number 6. Well, to do this one first, so it looks like the last one, we got to add 45 to both sides. We get x squared equals 45. Now we square root it up, and x equals plus or minus square root of 45. Of course, we got to simplify the square root of 45. That would be 9 and 5, and that's 3 and 3. So we got pair of 3's, so I can bring out a 3. But then I got this 5 left over, so it stays inside the radical. So we got plus or minus 3 root 5. All right, this next one will be pretty much the same. We got to subtract 40 so that we get the x squared by itself. And now we take the square root. So hopefully right now you're realizing, hey, my answer is going to have I in it. So x equals plus or minus the square root of negative 40. So let's simplify the square root of negative 40. Again, we'll deal with that negative in a second. Let's simplify 40. We got 4 and 10. That's 2 and 2, 2 and 5. So we got a pair of 2's, but we got those 2 left over. So we take the 2 on the outside, the 2 and the 5 are also on the inside from the boxed in numbers here. So we got 2 on the outside. We got that negative, so we have an I. And then on the inside, we have the 2 and the 5. We multiply those back together. We get 10. And that's how we can use the square root property to solve for our zeros. Sorry, it looks like we forgot one here. We got number 8 left still. I think that's it. Yep. So we need to subtract 3 from both sides so we can get our x squared term by itself. But we want to get x squared by itself. So we get to divide by 25. We get x squared equals 1. And of course we take the square root. So x equals plus or minus the square root of 1. Can we take the square root of 1? Yeah, it's 1. So our answers are positive and negative 1. So plus or minus 1. All right, we're going to review solving by factoring. So it's just putting together what we did with the factoring and then solving little equations. And again, it's a review of last year, so hopefully we remember this. But we always need to get it equal to 0 first, because we're going to use the zero product property. We'll add 56 to both sides, so it equals 0. Now there are no like terms on the left side, so we just put them in standard form. X squared plus 15x plus 56. We do our MA table. Two numbers that multiply to 56 and add it to 15. That would be 8 and 7. And because the coefficient of x squared is 1, we can skip right here. So x plus 8, x plus 7. Just right from here to there. Now, x plus 8 times x plus 7 equals 0. So that means either x plus 8 equals 0 or x plus 7 equals 0. Because to multiply two things and get 0, one of them has to be 0. So we subtract 8 from both sides to solve for this first one. X equals negative 8. Or we subtract 7 from both sides on the second equation, and we get x equals negative 7. So those are our two solutions there. Our two x-intercepts if we were to graph that. Got another one here. This one's going to be a little bit more work. We got to subtract 5 again because we want it equal to 0. So 6x squared minus 13x and then minus 5 because there are no like terms. Now we need to do our MA table. Well, remember, we need to multiply the 6 and then negative 5. And that will be our product that we want. We want them to multiply to negative 30 and still add up to that middle number of negative 13. So negative 15 and 2 are the numbers that work for us. So we can't skip right to the answer because we have a coefficient of x squared that's not 1. So we have to split up this middle term into negative 15x and plus 2x. So again, we just uncombined our like terms. That negative 13 became these two values instead. And they both have to have x because they still have to be like terms. Then we can factor by grouping. We got 3x we can take out of there. We're left with 2x minus 5. We can take 1 out of there, and we're still left with 2x minus 5, which is exactly what we want. So we get 2x minus 5. We take that out of both terms. We're left with 3x plus 1. So again, either that first set of parentheses equals 0 or the second set. So 2x minus 5 equals 0 or 3x plus 1 equals 0. So we got a little bit more work to do to solve this. Add 5, and then we have to divide by 2. So x equals 5 over 2, or 2.5, or 2.5, however you want to write it. We do the same thing with the other equation, subtract 1. We get 3x equals negative 1. Divide by 3, and x equals negative 1/3. And those are our two solutions there. So we had to do a little bit more work, aka this step, because we had a coefficient that wasn't 1 in front of the x squared. So that's how we can factor and use a zero product property. The last part that we're going to review is the quadratic formula. There it is at the right. We need to have that memorized. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The 2a is underneath everything. We also need the equation to equal 0 before we use the quadratic formula. So if we look at number 11, our a is going to be, when in standard form, the first coefficient, so negative 2. B will be the second coefficient, and C will be our constant. So now we just have to substitute it into our formula. So negative B plus or minus, that's how we get our two answers, B squared minus 4 times A times C, all divided by 2 times A. And now we just need to use our order of operations and simplify it. So of course, negative 3 is just a positive 3. Inside our radical, we get negative 3 squared, which is a positive 9. Negative 4 times negative 2 times 9 is a positive 72. And our denominator is 2 times negative 2. So we keep simplifying. Square root of 9 plus 72, of course, is 81, divided by negative 4. We can find the square root of 81. It is a perfect square. So let's find it. And the square root of 81 is 9, still over negative 4. So here, we can split this up into two answers. We got 3 plus 9 over negative 4 and 3 minus 9 over negative 4. So we simplify, 12 over negative 4. That gives us negative 3 for one of our solutions. The other one, we get negative 6 over negative 4, and that gives us a positive 3 over 2 for our other solution. And we just keep on working through that. It's the same thing. So these are the three ways that we can solve for zeros, either quadratic formula, factoring, or the square root property. We also could complete the square, but I don't hate you, so we're not going to do that. Let's look at number 12 here. It's not equal to 0 yet, so we have to add 4 to both sides. So we get x squared minus 3x plus 4, there's no like terms, equals 0. So A, it's not 0, because remember there's a 1 there. B is negative 3, C is 4. So we substitute this in. Negative b plus or minus square root of b squared minus 4 times a times c, all over 2 times a. So again, we do our order of operations, work our way through it to simplify it. Negative 3 is a positive 3. We got plus or minus, that is 9 minus 4 times 1 times 4 is 16 over 2. So we keep simplifying that more. 3 plus or minus the square root of negative 7 over 2. So hopefully right now you're realizing we got a negative inside the square root. We probably, well not probably, we do have an imaginary solution. So we're going to have I here. So that's the only thing we can simplify with the square root of 7. We poke out our I, we still have the 7 inside the square root, and it's all over 2. And you can write it together like this. This is actually what I prefer. But if you want to turn it into two separate answers, that of course is okay as well. So we get 3 plus or minus I root 7 over 2. It's ugly, but that's the solution. So that's what we got to use. And our last one up here. So we can subtract 10. Got to set it equal to 0. So now it is. We got an A of 2, B of 4, C of negative 10. So again, x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So we get negative 4 plus or minus square root of 16. Negative 4 times 2 times 10 is positive 80 over 4. That's negative 4 plus or minus the square root of 96 over 4. And of course, we have to simplify our 96. So we break it down to 6 and 16. That's 2 and 3. That's 4 and 4. And we can break that down even more. So at the end of it, we have 5 2's and a 3. So we got 2 pairs of 2's. So we'll bring out 2 2's. And we have the 2 and the 3 left over. So they stay inside the radical. So just the radical part is 4 root 6. But we still have the negative 4 plus or minus that over the 4. Well, we can do one last step to simplify. We can divide all 3 of these numbers, and they have to be, all 3 of them have to be divisible by the same number. We can divide them by 4. So we get negative 1, not nothing, plus or minus 1 root 6. And of course, you don't have to write the 1 in front of the root 6, but you can, and if that makes you feel better and it makes you understand it better, let's do that.